Hello, this is Justin with Lesser Dog Tutorials, and this is part 4 in our Metroidvania camera system tutorial for Unreal. And in this episode, we're going to be making the restrictors that can confine a camera in sections of a room. So what we'll be doing in this episode is creating the restrictor, but also kind of simplifying how the camera operates. For instance, we don't need player triggers to switch to cameras, but we'll use them in the restrictors. To kick things off, head to your Blueprints folder and duplicate the camera. And we'll just rename this Metroidvania Restrictor. All right, and then you can leave that and then go inside the camera and we're going to remove a lot of stuff. Head over to the construction script and we're going to delete the set box extent node with the player trigger extent and the set relative transform node with the player trigger transform. And then you can connect that back up so that the camera confine box can still be set up. And then head over and delete the player trigger transform and player trigger extent variables. Then in the event graph, delete the entire begin overlap section. We won't need that anymore. And then if we look at the event begin play function, we can see that it checks inside the player trigger box for the player and then adjusts the camera. So we won't be using the trigger box. Let's just use the camera confines box instead. And delete that player trigger box node, and then we can actually delete the player trigger box from the root. And now it should switch the camera to the player whenever we start. So open up the restrictor, and in order to get rid of some of these errors that are appearing before we can play, we'll need to delete the assigning of the current cam in the overlap section. So you can delete that. And then you can delete the same thing from the begin play section. We won't need that either. So if we compile, it should be good. We can save it and then we can try out the game. It looks like the camera does indeed switch right at the beginning, which is good. So back in the camera, we'll just kind of reposition this section here, make it aligned a little better. And then we'll head over to the door script. So open that up. And then the overlap sections are where we're going to be switching to the new camera. So what we'll need to do is create some variables. So create a variable called left camera and switch the type to the Metroidvania camera. And then duplicate that and just call this one right camera. So now we need to make it so that we can assign these cameras on begin play. So add a begin play node. And if you right click with context sensitive on and you say get overlapping actors, you'll see a list of all of the objects in the root. So we want the right spawn location first. And what this is going to do is it's going to filter out the Metroidvania camera. And then any that it finds, which should just be one, we're going to search for get ref and turn off context sensitive. You can see it under array. And then from that, we pull that and we'll cast to the Metroidvania camera. And then we will assign, since it's the right spawn location, we will assign the right camera to the result. And the same can be done for the left side. So you can just duplicate all of those nodes and swap out the corresponding variables. Cool. Now in the overlap section, we want to assign the camera based on which trigger has been hit for the door. So if you hit the right trigger, then the left camera is going to be the new current cam. If you hit the left trigger, then the right camera is going to be the new current cam. So drag out from the Metroidvania character reroute node, and we're going to just set the current cam right after we set the new spawn position. And the current cam that we're assigning is going to be based on which side we're triggering. So If you look at the door trigger right, this is where we're going to assign the left camera. So you bring that in and hook it up. And then for the bottom one, the right camera. And be sure to set up the target for both sides so it works. Now that the cameras are set, we need to actually transition to them. So open up the room transition at the end of the function and find the teleport and show player section. Right at the end, after we set the player hidden, we want to do the actual camera transition. So if you go to the restrictor event graph, you can see we still have the nodes there. So you can copy those, head back over to the game mode and paste them in. And then right at the end of set actor hidden in game, link up the set view target with blend in between that and the delay. We don't want to set the new view target as self. Instead, we want the camera. So this blue line here is already the character. So from that, we're going to pull out and we're going to get the current cam that we assigned just previously. And then that will be the new view target. You can compile and save that. And let's test it out and see if it works. And it transitions and it appears to be working perfectly without the player trigger boxes, which is great because we don't want that interfering with the player trigger boxes of the restrictors. Now, if you were to go back to the camera, you see that on event begin play and right after the get confines box, we scan for the player. So that's every camera is supposed to be scanning for the player. So let's just unhook it after get confines box. And we're going to copy what we made for the door. So select everything in the event begin play up to setting the right door and head over to the player event graph and add a begin play. And then you can paste all the nodes in and link them up. And then we need to replace the set right camera and the right spawn location. So swap out the right cam with the current cam and use the capsule component on the player for the get overlapping actors node. So now it should scan using the capsule component to find the current cam. And then that will only be once. So now we just need to set the view target with blend to the new camera. And then it should be instant, so no transition at all. And then make sure you hook up the current cam to the new view target. And then we want to go to the beginning of this and we want to add that delay again, just so we know that the camera's there before we assign it. All right, and if we test it out, appears to be working, everything seems fine. So back over in the camera, we can delete all these nodes that we don't need anymore. And now it looks a lot cleaner, easier to understand. And then we can select everything in the player and try to tidy things up a bit with comments. So we'll call this get starting cam, color that black. And the next one we'll say is movement. And then the jumping one, we'll try to encompass everything and move that over. And then the last one appears to be the set animation. There, now it's a little easier to understand at a glance. Now over in the door blueprint, we can select everything in event begin play and say that that's called get cameras. Then we can select all of the stuff in the trigger section and say that that's called room triggers. Or maybe it makes more sense just to call them door triggers. I don't know, it's up to you. So over in the event graph for the restrictor, delete everything after get confines box bounds in the event begin play section. And then you can delete the set view target with a blend, and then everything in the event tick you can delete. And then in the variables, delete all the camera variables, and then delete the cam follow player macros and the set camera position macro, and delete the lerp within confines macro. And then we won't be using the camera, so you can delete that from the root. All right, so now that everything is kind of trimmed down, we can kind of start making it a restrictor. So in the room size variables, we can just change that to be confiner width and confiner height. Now we need to create a few bools to say whether or not a side is locked. So create 4 bools and call them lock left, lock right, lock up, and lock down. And I'll just organize them into a category called restricting. And make sure each of these is set to visible so that when we're placing the restrictor, we can define where the camera will be locking. So in the event graph, after selecting the player trigger box, we need to add the on component end overlap in addition to the begin overlap because we need to define the restrictor when the player enters the trigger and exits the trigger. So you can duplicate the Metroidvania character cast. And before we continue in this, what we need to do is run a function on the camera passing in this restrictor to define where the camera is going to lock. So head back over to the camera and add a function called set restrictor active, and then add another one called set restrictor inactive. So on the set restrictor active, we want to add a new input called restrictor to activate and set that to the type restrictor. And on the set restrictor inactive, do the same thing, but we'll call this one restrictor to deactivate. Then you can save and compile that, and back over in the restrictor, we can pull up from the character on the begin overlap and get the current cam. And then from that, we're going to run the set restrictor active function. And the restrictor to activate will just be self. Same thing for the end overlap, get the current cam. And from that, run set restrictor inactive, connect it up, and then set restrictor to deactivate to self. Back over in the camera, we're going to create 4 new floats that are going to be temp, confine, min, and max X and Z. So create one for temp, confine, min X, temp, confine, max X, temp, confine, min Z, and temp, confine, max Z. Then we're going to head over to the lerp within confines function, and we're going to replace confine, min, and max with these temp confines. And the purpose of this is because we want to keep confine, min, and max holding the actual camera's confines, and then the temp confines will be the ones we assign on the fly. And if we ever need to go back to the camera confines, we'll just use the confine, min, and max. Now create a new macro called reset room confines, and make sure you add the in and out pins, and bring in the temp confine variables, and we're going to set each one of these. And we're going to set them using the confine, min, and max variables. So confine min X sets temp confine min X, confine max X sets temp confine max X, and so on. Now create another macro called set restrictor confines. And this is the macro that will be setting the new restrictor area that the camera will be bound in. So now if you go to the set restrictor active, you'll see that we passed in the restrictor to activate. So we'll need to assign that to a variable. So make a variable called active restrictor and set it to the type of the restrictor that we made. And I'll just move it into the components category. So for now, all we're going to do in this function is just set the active restrictor so that we have a reference to it, so that we can set the confines for the restrictor in the set restrictor confines function. So head back over to that. And in this one, we're just going to add a sequence node. And for the first 4, we're going to cycle through each of the lock bools that we made for the active restrictor. And if they are locked in a specific direction, that's when we will set the temp confines variables to be the confine variables inside the restrictor. So if it's lock left, and that's true, branch out from that and set the temp confine min X to be the active restrictors confinement X. And then the same goes for each of the other sides. So if it's lock right, then we're looking at max X. If it's lock up, we're looking at max Z. And if it's lock down, we're looking at min Z. So when it's all said and done, it should look like this, and feel free to pause the video to check. So back over in the set restrictor active function, right after we set the active restrictor, we want to do the set restrictor confines macro so that we can determine where the camera is going to be stopped. And then in the set restrictor inactive, we want to reset where the camera is being confined. So we want to put in the reset room confines function. And then right when the game starts, we want to make sure that we're doing the reset room confines. So back in the event graph, add it right after the get confines box bounds. That way it kind of sets the initial confining area of the camera. So if we drag in the restrictor and we're going to just kind of test it out, we can kind of put it wherever just to see if it works when the player walks into it. And that should work in that position. But before you hit play, make sure you're setting the restricting bools. So we'll do lock left and lock right. And let's see how that works. Okay, move to the other room, and then we walk into the restrictor, and now it's stopped. It won't follow until we leave, and then it resumes. But if we walk back into it, it snaps. So now our next task is to get it to lerp into the confines so it doesn't just snap. So I closed all the tabs except for just the camera because that's all we'll be needing from here on out. And I guess we could probably close some of these tabs here, like restrictor confines. So we can just leave restrictor active, restrictor inactive open. And we'll add a new variable, and we'll call this list of active restrictors because we want to keep track of every restrictor we enter, especially if we're entering one inside another. So make sure that this is set to the type of restrictor, and we're going to change the variable to an array. Okay, so what we'll want to do now is when a restrictor is active, we add it to the array, and when it's inactive, we remove it from the array, and we'll always use the top index of the list of active restrictors array. So add a return node, and then we're going to drag in the list of restrictors, and we're going to get it. And from that, we're just going to find add and link up the active restrictor to the variable that we'll be adding into the array. And that should be all for the setting the restrictor active. So the active restrictor gets set, it gets added to the list, the new confines are assigned, and it moves on. Now the set restrictor inactive function is going to be a little bit more complicated than the other one, so strap in. First, I'll just unlink the reset room confines and move that over. We'll need that later. And then at the beginning of this function, we're going to want to check if the restrictor we're going to deactivate is in the list of restrictors. So we'll do the contains node and kind of organize it a little bit. And then we'll branch out from that and see whether or not it actually contains the restrictor to deactivate. And if it's true and it does contain it, then we'll want to remove it from the list. So you can just copy and paste the get list of active restrictors and drag out from it and say remove. And we'll want to remove item. And then just link up the restrictor that we're removing. And you can link that up to the true from the branch. So if it finds the restrictor in the list, it removes it. That's good. So next we want to now check the length. So you can get the length node, and then we want to say equal to an integer of 0. So if now the list is equal to 0, that's when we want to reset the room confines. So branch out from that. And if it's true, reset room confines. Then we can drag in the active restrictor and set it to nothing. And then that's when we can return using a return node. And then that path is figured out. However, there's a couple falses that we need to figure out. So duplicate the set active restrictor, and from the branch that determines the length, if it's not equal to 0, meaning there is a restrictor in the list still, we'll want to set the top level. So get the list of restrictors, duplicate that, and then find the last index node. And that's going to be the restrictor we want to set. So if you drag out from the last index and we do a get, make sure you're getting a reference to and not a copy. And then assign that as the active restrictor. Then we'll want to set the new confines based on the restrictor. So get the set restrictor confines, link that up to the set active restrictor node, and then that goes to the return node. Now, if we go all the way back to the beginning, we can see that if the list does not contain the active restrictor, we're going to go straight to the return node. Great, and that should do it for the set restrictor active and inactive functions, so we can close those out. So back in the set restrictor confines macro, I added a comment box around what we have in there already. So I'm just going to add some stuff in between the inputs node and the sequence node. And the first thing we're going to need to do is reset the restrictor confines right at the beginning here, because if we're moving from one restrictor to another, we want to have a blank slate so that anytime we add new restrictor areas, we're adding it to where the camera originally was. So drag in the reset room confines and put that in right after the inputs node. So then this will reset it before we assign these temp confines over here. So we'll want to add a variable that is called isOutsideRestrictor X, and make sure that that's a bool. And then we'll make another one that's called isOutsideRestrictor Z. And these are going to determine whether or not we need to lerp to a position before we assign these new restrictor confines. So just drag them in, and we're going to do an OR, so either one of these. And then we're going to branch from that. And we'll move it up to right after the reset room confines for now. And what we'll need to do is, if either one of these is true, then we're going to leave immediately because we're not going to set the confines yet. We're going to be lerping. And if it's false, neither one is true, then we're just going to set the new confines, because that means the camera is inside the confines already. The only other time that we will need to immediately assign the new restrictor confines, even if the camera's outside the bounds, is if the player is transitioning between rooms. So let's get the player pawn, cast to the player, and then find out if the player is moving through a door and branch out from that. So we can just kind of move over a little bit. And then add the branch and then link it up. And then if it's true, then we are going to immediately set the new confines. And if it's false, we're going to need to lerp before we set the new confines. So that means that the branch that checks if the camera is outside X or Z, if it's true, it goes to the player to do the is moving through door check. And if it's false, it goes straight to setting the new confines. And then you can just clean this up and make it look a little nicer. So now we just need to create a function that will determine whether or not the camera is outside the restrictor X or Z. So create a new macro And we'll call this get restrictor data. And this function is purely going to determine where the camera is in relation to the new restrictor that we have entered. So add the in and out pins, and you can save it. And then we'll just drag it in here so we don't forget later, and that goes after reset room confines and before the branch that determines if it's outside restrictor X or Z. And while we're at it, let's open up reset room confines and then set outside restrictor X and Z to false. And then we can wire that up. So back in the get restrictor data function, we're going to drag in the camera and we're going to look for a node called get socket location. And then we're going to split the return value pin into its X, Y, and Z coordinates. Next, drag in the active restrictor, and from that, we're going to get confine min X. Then you can duplicate the active restrictor and get confine max X. And I put them on either side of the socket location like this. Our goal here is just going to be to compare the location of the camera to the active restrictor's confine min X and confine max X. So if you wanted to compare it to the confine min X, you want to see if confine min X is less than the camera's X location. And then you want to see if the camera's X location is greater than confine max X. And if these are true, that means it's outside the bounds. However, we also want to see if the restrictor is supposed to lock the camera in these bounds. So bring out the lock left and lock right bools of the restrictor, and we're going to do an AND bool to see if both of these are true for each side. So you can add a branch for the min X bools, and this is the first branch we're going to hit after we get into this function. So when we first come into the function, we're going to test and see if the restrictor's confine min X is to the right of the camera, and if lock left is true. And if it is, we're going to first create a variable called inside restrictor X. Now this is going to be a float, and this will just hold the information of where the camera needs to move to get inside the restrictor. And if these bools are true, then it's going to be equal to confine min X. However, if this is false, we're going to move to the other branch, testing if the camera is to the right of the confining area. And if it is, we're going to set inside restrictor X again, but this time it's going to be equal to confine max X. And the last thing we need to do in this section regarding the X location is set is outside restrictor X bool to true, so that the camera knows it needs to lerp to a position before it sets the new confining area. And then we can copy everything here and paste it next to it, because we'll be running everything again, but this time using the Z locations. So make sure the output pins of the last branch and of the bool that we're setting, the is outside restrictor X, both go to the same spot, which is the first branch that we're testing in the Z area. So you can just create a little reroute node that goes up into that line. And then we begin the process of changing each of these variables for the min and max Z locations. And then don't forget to make a new variable called inside restrictor Z that we'll be using to replace the inside restrictor X variables. And don't forget, before you leave, make sure the return value z is being used for both the greater than and less than nodes. Now I've opened up the cam follow player X, and what we're going to need to do is have an alternate route in this where it either follows the player or it's lerping into the position it needs to be. So from the Metroidvania character cast, we're going to add a branch. And the condition that we're going to be testing is the isOutsideRestrictor X bool that we made before. And if it's false, that means we can follow the player and that's fine. But if it's true, we're going to be doing some more stuff. Let's start by duplicating the current cam lerping position X node and hooking that up to the true output pin of the branch. And then from the set float node, you can just go straight out. And then duplicate the finterp2 node. And just like the other one, the current value is going to be the camera's socket location X, and then the return value will set the lerping position X variable. However, instead of the target being the capsule component, it's going to be the inside restrictor X float. And then we want to copy delta time and put that into the delta time input. And we'll leave the interp speed at 4. And now we need to check and make sure that the camera is near the position it needs to be or close enough. So we'll need a node called nearly equal float. And we'll be comparing lerping position X to inside restrictor X with an error tolerance of 1. And it returns a bool, so we're going to use a branch to determine what to do if it's true or false. And if it's false, meaning it's not equal, we're just going to leave and go to the out. But if it's true, we're going to set isOutsideRestrictor X to false. And then we're going to set the restrictor confines. So that does it for the CamFollowPlayer X, but we need to recreate it again for CamFollowPlayer Z. So grab all of these nodes. Everything that we added to this, we're going to copy. And then in the CamFollowPlayer Z, we'll paste it. And we got to make sure everything lines up the right way. So right after casting to the player is the branch that checks if it's outside restrictor Z. And then we need to link up the true and false to the correct set nodes. So true would be at the top and false would be at the bottom. And then the output we want to link up just like we did before. However, now we got to swap these variables. So isOutsideRestrictor Z, inside restrictor Z, current cam lerping position Z, inside restrictor Z here. Now the only thing left is to make sure that the camera's socket location is using the Z location. So the finterp2 needs to be dragged down to the Z. And that should be everything that we need for both the X and Z location for cam follow. So compile and save, and let's test it out. Okay, started playing, moving to the next room. And we enter the restrictor here, and it looks like it is lerping in and out of the restrictor. That's great. But there are a few things we can do to make this even better. So open up the Metroidvania character and go to the viewport. And just switch it to right and lit. Now if we add a sphere collision into the hierarchy here, and we can call this cam target, and we'll set the size, the radius to like 8, something small. We can move it out in front of the character a little bit and have the camera focus on this. So we want to make sure that it is hidden in game. And then we'll need to go over to the cam follow player, and instead of the capsule component, we want to replace that with the cam target we just made. So from the cast to Metroidvania character, you can drag out and find the cam target and make that the new target for the get world location. And do the same thing in the cam follow player X. Now it should follow that target. And we can test it out and see So now the camera has a little bit of a lead in front of the player. However, the target is triggering the door, so let's turn off any sort of overlap. So in the collision presets, you can switch that to no collision, and that should fix it so it doesn't trigger the door. Yeah, that looks better. Great, so now we have a little bit of a lead in front of the player, and the camera will move to see a little bit more of the direction the player's facing. But now I want to make the second room a little bit larger to kind of test more of the restrictor's abilities. So I'm going to make the tile map 2 screens high, and then at the end here, I'm just going to add a little vertical area to go down to the lower level. There, so it sort of looks like this. So I'll be able to go to the right side and go down to the lower level. And then I want to make sure that the camera's room height is 2 so we can encompass everything that we made. Make sure that's centered. And then for the top restrictor, I'm just going to make it extend all the way across the top. So the width is going to be 3 screens, and then I'm going to make sure that's centered. And actually what I'm going to do is change the color of the sphere so that's not, I don't get it confused. So I'm just going to select some other random debug material just to separate them. This can be whatever you want. And then now I can tell them apart from the camera. Now make sure to extend the trigger so it encompasses where the player will be. And I just move the trigger over a little bit because I want it to be left of where the vertical restrictor is going to be. So I add another one and I make sure that it's centered on the right side. And it needs to be 2 screens tall. And I center that. And I need to make the player trigger on the Z-axis larger. So now when a player walks into this, it should lock left, and then the top one will lock only below it. There. So then we can test kind of the transition from one restrictor into a vertical restrictor and then back into the main camera so that there won't be a restrictor if I go to the bottom. So first thing, it slides right over and now it's locked vertically, which is great. It won't show below. And now I've entered the vertical area. And now when I leave the vertical area, it's now completely unlocked. And now it locks back into the vertical. And now it's completely open. Yeah, everything appears to be working perfectly. Great. So that does it for this tutorial. Thank you very much for watching. And I hope this really helped you. I apologize if it was a little too fast, but you can pause it. You can slow the speed down, right? All right. So if you liked what you see, please subscribe. Please like the video. And I'll see you next time.